Okay, so I just started the recording. So this bike here is basically what we're going to be working on CADing over the next few sessions. Doing the whole bike will take quite a while, so I'm not sure if we will end up getting to all of that, but this was going to be a reference for going through all the different tools and kind of setups and all the different skills you'll need to kind of CAD effectively. So um, today we're going to start off with just doing some basics, learning how SolidWorks works, and then we're going to make our first part for this bike, which is going to be this part here, this little transfer pedal bar, which rotates
I
the
can't.
center tube.
You're not screen sharing.
Oh, I'm not screen sharing. Okay, thank you. Hold on. Let me see. Thank you for speaking up. Okay, can you see now?
Yeah.
Okay, good. Okay, so yeah, we'll be starting with this part here, which is this bar here that connects to the pedal in the center. I don't know what it's called. We're gonna make this bar, and I'm gonna show you kind of step by step all the tools. Okay, so I'm gonna hop back into SolidWorks first. So if you haven't already opened up SolidWorks, and this is the first screen you should be kind of greeted with. If you've worked with SolidWorks before, you may get a pop-up in front that will say, it'll show some recent parts, things that you might have worked on before to open up and stuff like that, which you can probably start a new part from there as well, but we're going to start from this blank page. So much like most windows in Microsoft, the top left will have all of your kind of tools and bars. On the right side here, by default, you can change all of these, by the way. You have this Experience Marketplace tab. In here, you'll find a lot of learning resources. So there's forums online for SolidWorks where you can find a lot of the information you might have questions on. There's a lot of benchmark testing and all this stuff for SolidWorks itself, which some people may want to do if you're having trouble with performance. SolidWorks does primarily use your CPU. Almost 100%. It's very little use on GPU despite the large amount of graphics that are displayed within it, so keep that in mind. It has design library, so you can pull CAD parts for standard design. So for example, screws, nuts, washers, gears, motors, all that kind of stuff. SolidWorks has a toolbox. You can just pull those into your design. When you're building larger assemblies, you can basically use those and you don't have to create everything from scratch. You can have a file explorer, basically go through all your different files. Some palettes, I think that's for drawings. You can add appearances, so this basically changes the material properties as well as the appearance of all the parts that you make. So you can basically paint all the sections and make it look nice and clean. And then we have custom properties, which you don't have to worry about just yet. Okay, so first thing we want to do is create a new part. So in the top left, you have home, you have this little new page and open. So just go ahead and hit new. You'll see this pop up. There's three different options. There's part, assembly, and drawing. So kind of what we talked about last week. Mostly what we're going to working with is parts. Assembly is exactly what it says, is you assemble different 2D parts into a larger object. So we're going to start with parts today, move on to assemblies, and at some point we'll probably touch drawings as well, although that will be kind of a side point. Just going back to the reference first. This here, so this CAD file I have here, can anyone tell me, is this a part or an assembly? Which one should be pretty obvious?
Assembly.
Good, right, of course. And roughly how many parts do you think this has? I'm sure we can probably get the exact number, but quite a few, right? And so it has quite a few parts, and it's important to note that each part is not necessarily unique, right? So when you make an assembly like this, a lot of times you'll reuse parts over and over again. So that's one of the benefits of having parts and sub-assemblies. in your design. You don't have to redo. So for example, these wheels will be the same. The shafts here will be the same. The grips here are likely the same. All the screws and hardware, the chains, many of these parts will be the same. And it'll be the same part copied over and over and over again into a chain shape. Okay, just keep that in mind as well. Okay, going back to our part, we have this secondary bar that appears now that we're inside of a part. There's a lot of different tabs here, and so I'm not going to go through all of them because most of them are not necessary. The main three you really need to worry about are features, sketch, and evaluate. I don't think I've even used markup before. That might be useful as well if you're trying to illustrate something. But basically, you always want to start with a sketch. That's basically you draw something in 2D, and as we talked about, basically you can extrude or revolve that by pulling it out into 3D. Okay, there's a bunch of different operations we can do here, but all of them are basically just shortcuts for things you can do by drawing lines, squares, circles, spheres, all of these things. And if you define them properly, you can basically make them into a solid shape, and these are just shortcuts for doing those things, right? And on the left side here, we have this bar, right? I think this is called our feature tree. You hover over here, feature manager design tree, yeah. This will show us, hello? Do you have a question? No? Okay. So we have the design tree on the left. And so this will show us all of the, basically everything we've put into the part file so far. So it has a history. So if you want to undo anything you've done or whatever, it has that. Sensors we'll get into later. Annotations we'll get into later. Material, so we can define the material for the part that we're going to be working with. So there's a huge library inside of SolidWorks of what different materials you can use. So if we look at this this material here, can anyone guess what this is? Please feel free to unmute and answer as well. What do you think this is made out of? Probably some metal.
Carbon fiber.
Could be carbon fiber as well. Yeah. Let's go with carbon fiber then. There should be some carbon fiber. Yep, carbon fibers. I don't know which one specifically is most usable for this, so I'll just pick a random one. So now it's made of carbon fiber. And it's likely this will not show any difference in the visual aspect of the CAD model, but it will affect the mass properties and evaluations later on. We also have 3 planes, so you can see top, front, and right plane. So that's just relative to your part. You define what your front, top, and right is, and you can make different sketches on those. And then you have your origin point. So we also talked about last week about defining your parts properly. So the origin point in the center here is your main and best reference point. So that's the first thing you typically want to figure out where you want to start your part. So if we're going to be building this part, which I'll probably save until the second hour, the origin would probably be in the middle of one of these circles, just to basically ease the creation of the geometry around one side of this, and then use the other side as reference.
Sorry, Jeremy.
Yep.
What did you choose under carbon fiber? Which option?
I chose Thornell Matt's VMA, although that was just a random choice because I'm not familiar with the SolidWorks materials enough to know which one of these is the proper one to use for mechanical strength. The way that the carbon fiber is highly, like, the mechanical properties of it, because it's a composite, are highly dependent on how it's manufactured. So even these mass densities and whatever, I mean, this one has no other properties other than the mass density in it, so it's not particularly useful to begin with. But you can define all of these, shear modulus, Poisson ratio, elasticity modulus, all of these things, yield strengths. Yield strength is probably the most important one for carbon fiber. You can define all of those in a custom material as well. And you can do simulations in SolidWorks as well. So there's a simulation tab here. You can do simulations on, for example, how hard you'd have to push on the pedal to break that carbon fiber. But again, you would need the proper material properties to actually effectively do those simulations, which you would need to know beforehand outside of SolidWorks to effectively simulate. So we'll just start off with some basic parts. So last week we talked about basic shapes, so we can do some basic shapes. We'll start off with a sketch. So if you go to the sketch tab here, there's a sketch button in the top left, and you'll have a bunch of standardized tools here. Obviously, with a line and a circle, you can make most everything you need, but of course SolidWorks has shortcuts for other things you can do. So for example, under square, there's a few different ways to define a square or even a parallelogram. So you can see you define a rectangle by 2 corners. You can define it by a center dot and a corner dot. You can define it by 3 points, by a corner, 3 points, and a center, or a parallelogram. You have different arcs, different circles. You can do perimeter circle, normal circle, ellipses, parabolas, slots, center point slots, and arc slots. These are also incredibly useful. We use slots a lot on this team for 3D printing, because sometimes the parts that we're working with don't have the best locational tolerance. So how we tend to get around that is by creating slots, which allow us to create looser tolerances with our parts, and end up helping us a lot in making sure parts fit together properly. We also have hexagons and stuff like that. For example, when we do 3D prints, we will tend to include a hexagonal hole in the 3D print to allow a nut to be placed into it, so we don't need 2 wrenches basically to put a screw in. Ease of life thing, but it takes 5 seconds to do in CAD, and it takes up a lot of it reduces a lot of physical strain from taking screws in and off in person. Okay, so now that we have a sketch, we need to determine which plane we're going to be clicking on. Typically, you want to start with your front plane first, and this is just a kind of a communication in graphical engineering, like a standard. Front is typically defined as the most complex oriented side of an object. So for example, a bike, this would be your front view, right? Even though obviously the front of a bike, as most people would define it, is this, the most information that can be gathered from this CAD model is this face here. So if we were to define our kind of CAD space for this would be our front view, this would be our right view, and this would be our top view. Does that make sense?
Oh, I have a quick question.
Yeah.
Uh, for the pedal, right? The
Yeah.
sprocket, the shaft, and the pedal.
Yeah.
If you made would the origin change if you like made it all in one, like periodically, or would it only be like in the middle of the shaft?
So it depends on how you define it. If you did it as a sub-assembly, then it would likely be the origin at the center of whichever part you made the assembly with first. So for example, if I made them separately and I defined the origin of is this a sprocket? Is that what that's called? Whatever the arm is.
At the shaft?
Sure,
I don't
we'll
know.
call it that. If we define the origin of the shaft as the left circle here, basically, and the pedal as the base of the pedal that connects there, for example. If we made the assembly using the shaft part, the origin would likely be the center of that part, and then when we added the pedal, it would have its own origin, the arm would have its own origin, and the assembly itself would have its own origin, if that makes sense. So
Oh, okay, okay.
every part, every assembly has its own reference origin, and everything else is defined based on that. And that's typically not something you need to worry about too much in assemblies. It's more for parts you need to worry about that.
Oh, okay, got you. Thank you.
No worries. Also, typically we wouldn't want to do this in one part. The reason being, this pedal, right? We're going to be animating this as well, right? We're animating the motion of this. And that's impossible to do if this is one part, because what will happen is this pedal will rotate with the shaft. And so basically this won't stay flat. The way we'll animate this is we're going to keep this pedal parallel to the ground, as if you were biking it. In real life, I know it rotates a little bit with your foot angle and stuff like that, but it'll look really weird if it's all one part. So typically what we want to do is our final main assembly, we want to have everything that moves should be a separate part or separate subassembly. So for example, the back and front wheel, every single part that we make for those should be under one subassembly, and that subassembly will then be brought into our main assembly. And so everything within that wheel assembly will move together as one part, and the main assembly will only have the different subassemblies together that move independently, if that makes sense. If not, it'll make more sense when we start working with assemblies. So don't fret just yet. Okay, so we're looking at our part now. We have the front view. Okay, and we're just going to make a simple cube. So the easiest way we want to do that, for example, is if we wanted to define the center or the origin to be the center of our cube, we're going to use the center rectangle. Okay, we're going to click on the center here. Right, you can see that to the bottom right corner of my mouse, there's a little intersection constraint there that pops up. Okay, so somebody mentioned that in the classroom yesterday or last week. That's a constraint there. So that basically means that the point that I'm clicking is going to be on a line. Okay, in this case, it's on our origin. So we know that once I click off and make this, when I click this origin, I won't be able to move the square anymore, right? Versus if I were to start it up here, right? You can see I can click, I can drag this around now. We don't want that. If you can ever drag something, it means it's not defined properly, right? And so I can drag this around. We don't want that. We always want locational definitions for our parts. So I'm going to delete these. You can also Control Z to delete them. Okay, so now we have this rectangle here, right?
Sorry, Jeremy.
Yep. What's up?
So you you clicked on the corner rectangle, then you clicked in the middle, and then you constrained. How did you constrain it?
This is a center rectangle, just to
Center rectangle?
Yeah, and then so we click on the center, and basically you just want to make sure that the little intersection constraint appears there. So that should be around the origin, should be around the center point here. So you can probably see that. And if it's too small, I might be able to zoom in a little bit. I don't know.
So once you clicked on the center, what image appeared? Sorry, I was looking at my screen. So
yeah, so once you click on the center, you'll basically see a lighter version of this square. And once you move your mouse out, you'll see the preview of this. And when you click, it'll finalize as this shape.
Okay, so how do we? So it automatically constrains once you click on the center.
Yeah, it'll automatically make a few constraints. So because this is a rectangle, there's some definitions it'll automatically make. So for example, it'll automatically make the top and bottom parallel, the left and right parallel, and then it'll add these cross lines here from the corners, which are equal to each other, which means that the corners will be 90-degree angles. So these shortcuts that you use up here will always be fully defined when you put them in. So you don't have to worry about, your corners being, off by a little bit or anything like that. Whenever you use these tools, the definitions will be correct. The only thing is the scale will not yet be set. That's what I'll talk about next. So first thing is I mentioned in the classroom last week as well of always checking whether your parts are defined or not, right? So in the bottom right corner, you can see I have this message here. It's kind of hard to see. It's mixed in with all this other stuff. But you can see it's underdefined. Right? So in this case, we're underdefined because the size, the scale of this object is not yet defined, right? So you can imagine this right now is defined as in vector space, right? The shape of this is defined, but the size of it is not, right? In either way, it's still a rectangle. So what we're going to do now is we're going to make some definitions. I want this to be a cube. So I want these two sides, the vertical and the horizontal, to be the same, right? So what I'm going to do is I'm going to click on this left line here. I'm going to hold Control and then click on the top line. Okay. So you see on the left side here, we've moved from the feature manager design tree to the property manager tree. Okay. And so properties are just obviously properties that any shape or sketch or anything in your feature tree will have. So I've selected two lines, so I'm selecting their common properties now, not their individual ones. They can have individual properties. So for example, this one, you can see this one has a property that's vertical, right? But when I select both of them, I'm only looking at their common properties, right? So we're going to look at the existing relations, right? There's nothing relating these two to each other. So there's a bunch of ones we can add down here. So these relationships, these constraints. So I can make them horizontal to each other, which will break, right? Because this one's already vertical and this one's horizontal. So if I try to make this one horizontal with this one, the program's going to spit out a huge error because we've created an impossible definition, right? Same thing with collinear, that's impossible because this would have to be rotated to horizontal. Perpendicular we could create if we wanted to, so we can add that just for demonstrations, right? So if I wanted to make sure that this is a 90-degree angle, I can make them perpendicular, right? And you can see the constraint will always appear in a little indicator box here right next to it, okay? And if you're ever unsure, you can normally click on these and it'll pop up here. So I'm going to click these again, and what we want to do is make them equal to each other. I would never use fix, by the way. Fix here anchors them in location. So for example, if I wanted this not to move, I could create it as an anchor, right? And then I'll be able to drag this around, but it's not really fully defined. And even in the bottom right here, it'll say fully defined, but we haven't actually defined what the size of this shape is, right? We typically don't want to do that. I'm going to click and just delete that. So I just clicked on it and pressed my delete key. So I'm going to set these two and just set them equal to each other. Okay. And at this point we have our square, right? We're still underdefined though. We still haven't set the scale. So we'll just set this as a 1 meter by 1 meter by 1 meter cube. Okay. So as soon as you start worrying about scale, there's a few things you need to take into account. So when you're making your first part, in the bottom right corner here, you'll be asked for which dimensional scale, like which standard units you want to do. Our team, on TMAV, we always use millimeters, grams per second, okay? The reason for this is the vast majority of the parts that we manufacture on this team are designed for metric screws, metric fasteners, metric parts, and all that stuff. They typically are significantly less than the scale of a meter. And we worry about grams. So when we're worried about part sizes for the drones, we don't worry about kilograms because we don't typically have kilograms to play with. We typically optimize on the scale of grams, which is why we use millimeters, grams per second. You can also use inch, pound per second for different projects, and you can always switch these even during a project, although I highly recommend you try to stick to the same one as much as possible. If you ever leave a sketch by accident, like I did by clicking there, you can always just double click back in. Oh, I guess that doesn't work anymore. Or you can click sketch back at the top and it'll pull you back into your sketch. Okay. So we will now make this into a 3D object. First, we just have to define the scaling. So in the top left, we have smart dimension.
Sorry.
Yeah.
I just changed my units and it changed the color of my drawing. It's like gray now.
Yep.
And,
yep.
yeah.
So that's typical. So you can see if I click another one, it'll gray out mine as well. And that's basically just because the Solidworks has to basically redefine everything in your sketch in terms of the new unit system you pick, right? So that's okay. If you go back to click on your sketch at the top, sketch, and then sketch, it'll pull you back into the mode you were in before. Okay.
Okay, yeah. Thank you.
No worries. Okay, and then what we're going to do is... Sorry, 1 second. I have to fix something. Sorry, something went wrong with the recording. I have to fix...
Sorry, Jeremy, you're recording this, right?
I am recording it, yeah. I'm just running into an
Good.
issue with it right now. Sorry.
Good.
I'm trying to include the Discord as well, just so people can tell who's talking. I'm just gonna throw that over there. Hopefully that's big enough to tell from you two. Maybe not, but who knows. Okay, yeah, so we're gonna pull this into 3D. So last thing we're gonna do is smart dimension it. So in the top left, we have smart dimension, and once you click the drop down under smart dimension, you see there's a bunch of different dimensions here. Realistically, I almost never touch any of these. Smart dimension is almost always good enough for what you're doing. If you ever need to worry about other types of smart dimension, or other types of dimensioning, is really just if you're having trouble with smart dimension. So for example, when I click on here, sometimes when you drag across for different shapes, it'll kind of change which one. So the idea behind smart dimension is it automatically chooses which one of these based on where your mouse is best for your application. And it's pretty smart, so most of the time it gets what you want. I click here, I obviously mean to, do this, right? If I click between these two, it'll take the angle, right? I can define it by these different angles. I can define, what else? Define the distance for the top line across by clicking these lines. There's a bunch of different ways you can click around, and I encourage you to mess around with that and kind of get familiar with it. The easy way, typically, I always just define the line by clicking on it. Okay, and so by default, it's going to pop up with this little modify window here, which will be defined in millimeters, given that's our definition. But I've already said I want to do this in meters, right? There's two ways you can do that. You can type in 1,000 millimeters, right? Which is correct, but it's probably not the most optimal way to do this, right? Especially, if you haven't been working in engineering for a long time, or you're maybe new in your degree, you might not typically know the conversions between inches and centimeters and decimeters and meters and all of these things off the top of your head. Typically, once you get the third, fourth year, you probably should know them off by heart. But when you're early in the degree, you might not. You might make some mistakes. It's easy to think sometimes 100 millimeters is a meter. If you're not paying attention, you're tired, something like that. So the easiest way to do it is type in 1 meter. Okay, you type 1 meter. I type that in, and you see it automatically converts that to 1,000 meters. So SolidWorks is very, very intelligent with how it does its definitions. Okay. I can also do, for example, 10 inches, right? Or IN, I guess, is the definition for inch. And it'll also do it in inches, right? That's also important to note as well. You can do anything like that. You can also drag this bar here to dynamically scale it up and down. You can rebuild, regenerate the model. So sometimes when you're doing, when you're trying to change the dimension of a very complex part, SolidWorks won't update the model every time you make a change, just because of the processing power it'll use. So it'll let you finalize your changes and then recalculate the whole model. So this can help you do that in this window. Most of these you don't have to worry about, so I'm just going to click OK. Now, one thing I think is incredibly important to note, I don't know if you guys saw this on the bottom right here, but this gives you your X and Y position of your mouse relative, I believe, to the origin. Right? Now, when I put my hovered my mouse over here before I made this dimension, and it was around 45. Okay, so it's important to note as well that the shape that you first make will not change size when you put this first thing. It scales the entire reference frame dimension size to your shape. So for example, if I made I don't know, two squares inside here. The middle one was 1 inch, but I didn't set that dimension, and the outer one I wanted to be massive, right? I click on the outer one and I define it as, I don't know, 10,000 meters or whatever I want it to be. It'll keep the middle one the same proportional size as the outside one, if that makes sense. So whenever you define the first dimension in your drawing, in your part, that's going to be the reference dimension for the entire design. Just keep that in mind. Okay, next thing we're going to do is pop into the features tab on the top left. And so you can see we have a lot of grayed out ones just because the specific design that we're at right now, the phase we're at, these are the only shortcuts that have all of their prerequisites met. Right, again, we'll note in the bottom right, you can see our design is fully defined. Okay? So I'm just going to click Extrude Boss Space. And you can see we get this little window. Right, so now I can click in with my middle mouse button. I can drag this around and take a look. I can click on this little arrow and pull out or push in, either way, to create our kind of 3D space, right?
Excuse me, can you do that again? I was looking away.
Notice. So it's this button, extrude boss space here in the top left corner. All right, so you go to features, extrude boss space, and then you just need to define in the bottom here the selected contours, what you're trying to extrude into the third dimension, right? And so there's a little arrow here you can click to pull out or push back in, right? This is also bidirectional, so you can also do it a different amount in different directions, whatever you need to do, right? And so I'm going to click off the second direction there. Ignore thin feature. If this ever pops up, you should basically always select that as null, as 0. Turn that off until you know what it does. And if you
Pardon
know what
me.
it... Yep.
What if you don't have a features tab?
You should have a features tab. If not, you've made a
I
mistake up until this point.
You gotta click out of the.
Somehow I think I might be in the wrong one. I think I have assembly, layout, sketch, markup, evaluate, SolidWorks sim, MBD, and SolidWorks cam, and that's it.
I think you may have opened SolidWorks assembly instead of SolidWorks
God
part.
damn it!
Yeah, no worries. Just go ahead and start again. You should be able to catch up to this point pretty quickly. So on the left
Jeremy,
side here, yep.
Why is your the back part of your shape, the drawing, purple? Mine is gray or something.
Yeah, so if I remove this, right, is that what you see now, or?
Yes, that's what I see.
Yeah,
That's
so
how mine.
basically in the bottom left, right, so you can see what SolidWorks is doing is it's automatically assuming what I want, right? I haven't given it any input. I just told it I want to extrude something, right? It knows this is the last part I worked on. So what it's doing is just, it's assuming this is what I want to extrude, right? But it's not defining that 100%. Like if I click yes here, I'm accepting the assumption and it will extrude. But by going into select contours here, I can force what I want it to do. So if I click on that, it's now forcing that as my extrusion, right? That'll make more sense when you know, there comes a situation or comes a time where there may be like 4 or 5 different options that SolidWorks could choose from as what you want to extrude. For example, if you have 5 or 6 squares that are overlapping and you want one part of that to extrude but not all of it, SolidWorks is probably going to get that wrong. And at that point, that's when you have to force which contour you want to extrude. Does that make sense?
So now I selected region 1, sketch 1, region 1. Is that correct?
That's correct. Yeah.
But mine is still not purple anymore. Okay.
It should be purple. If not, it's not a big deal.
It's brown like that. Yeah, it looks like that. Okay, good.
Yeah, it should pull into 3D either way. If the extrusion doesn't work, then be concerned. But yep.
Can you just go over the little shortcuts on how you rotate the shape and how you move it in 3D?
Yep.
How you move it in a plane? Yep.
Yeah, so the middle mouse button by default is your rotation, right? So you click that and then basically clicks on the screen and then you move your mouse around to rotate. Okay. Holding control and clicking that will pan, right? Is there anything else you need? I can't remember. Is that all the movements?
What if you're on laptop and you don't have a mouse?
I honestly don't recommend catting without a mouse ever. You can get away with it for simple parts, but to be honest, it's very difficult. I don't actually know how to do that very well. There is one tool you can use, which is this one here. It's kind of up in the middle of these ones here, view orientation, right? You can click on this and it'll give you all the different layouts, so you can kind of click around between these to give you potentially a better view. I think there's another button, I can't remember, I think it's this thing. Yeah, so if you press space and you click on this guy up here, view selector, I think it's control spacebar, it'll pull you into this view, so you can actually click corners as well if you want like isometric views or like angle views. Right, so that's control spacebar. Right.
Oh, okay. Yeah, I could just get a mouse right now as well. Just do.
Yeah, I recommend always using a mouse. Like easier parts and stuff, it's doable to do without, but it's just like it's one of those quality of life things that like you really just don't want to do. You know, if any of you use like a game or something, it's like the equivalent of playing like an FPS game with a trackpad. Like, you just don't do it, right? You can, but you really shouldn't. It's also like on lower end laptops as well. You'll run into the problem of your trackpad and mouse and keyboard will sometimes collide for bandwidth on the like serial ports for your computer, and it'll like skip some things. It's just, yeah, get a mouse. It's worth it. Okay. So now that we have this, we know we're doing extrusion. Okay, make sure we take off direction 2 and thin feature. We don't want to worry about those. Just worry about direction 1. And so there's a few things even here we still need to define. And obviously, like, once you do this a few times, you can blow past this in literally under a second. We're just going to go through it in detail one time just to make sure everyone's on the same page. The extrusion, the contour, so this region, this sketch that we made, the rectangle, the square here, is not where, by default again, SolidWorks is assuming that I want to start the extrusion there. That's not necessarily the case. So for example, if I wanted to make a part that's floating off of something, or I wanted to, for example, cut into something, but I didn't have a smooth surface to cut from, to make the drawing from, I may make the drawing from, you know, the bottom plane and then jump the cut up into something else, right? Again, that doesn't need to make sense. It'll make more sense when we get into a situation like that. And then what we're going to do is define that. So if you said it is from sketch plane, right, it'll take the plane that you drew on and extrude from there. You can also extrude it from another surface. We don't have another one to click, so that option won't be able to do anything. You can extrude it from a vertex, so I should be able to click on this, that vertex. It might not work because this is the same as the sketch surface, or you can do an offset, right? Offset is the most common one. You know, I can offset this, and you can see the extrusion will move by this offset. And so I can make basically a floating cube outside of the origin reference frame, right? We're just going to leave this sketch plane for now because that's just fine for our purposes. But just keep in mind that's the definition. In direction 1, we have another bunch of options here. So this, again, for simple extrusions is pretty straightforward. Typically, you either do blind or you do up to a surface or vertex. In some occasions, you will also use midplane. It's very rare you use offset from surface or up to body. Okay, so typically blind. So if you wanted to make, you know, your 1 meter cube, you would type in 1 meter or 1,000 millimeters, and this is your 1 meter cube, right? And then if I click OK in the corner, you're done. That's your 1 meter cube. But one thing I want to do is I want my cube to have its origin in the center, right? That's what we said from the start. And right now, the origin is at the bottom of the cube, right? It's in the bottom of the center of the cube. And so what I'm going to do is I'm going to click midplane. And so what this will do is it's going to split into 2 directions, the top and bottom, right? So you can see now I no longer have the option for 2 directions because I'm using midplane. It'll split the top and bottom equally, and it'll split that, that size in half, okay? I'm going to leave it at 1 meter. And I'm going to hit OK. That's all we have to worry about in this tool. Okay, and there we have our carbon fiber tube, and our carbon fiber cube. And you can see that SolidWorks did actually pull in the carbon fiber mesh as well. Okay? So there's your first part done. So next thing we're going to do is talk about naming conventions. So in the top here, you click Save, Save As, right? Go into my documents and just make a random folder. I'll do this TMAV SolidWorks. Okay. Open TMAV SolidWorks, and then what we typically do on this team is each project will have a number. So let's say this is like 45. Okay, and we'll say this is the bicycle CAD, okay? So we typically always start it with a number and then a name describing what the project is about, and that's your main folder, okay? And I can write this down in the Discord channel and pin it as well, just so we have this for future reference. We open it up, within the CAD, we're going to have one main assembly, which we won't have right now. But what that'll look like is this will be a SolidWorks assembly, and we're going to start it off with 0, 0. Okay? The reason why we want to do this is we want to have one number, right? So we can organize all of our parts and assemblies by number in a hierarchy where our main assembly, where all of our moving parts and everything kind of combine together, is at the very top. Right? We always want to be able to find that easy. We want other people to find it easy, and we want to keep that standardized. So what we normally do is we have something like this: assembly, and we can say like bike cat or something. Bicycle cat. Okay, and that would be our main assembly that we'll have. And then each subsequent part that we put inside that assembly will then have a part number that increases from there, right? And that's for basic projects. What we do for more advanced projects, so for example, Baby Shark, that drone that some of you saw today, or some of you may have seen in previous meetings, that was a very complicated CAD. We had propulsion systems, we had arm systems, we had airfoil systems, there's a lot. And so within this CAD folder, this bicycle CAD folder, we had subfolders, right? And so, for example, in this we would have 01 dash 01 dash propulsion, let's say, right? Propulsion or something like that. 02 would be wing structure, 03 would be structural, 04 would be avionics, something like that, just to break up the sub CADs, and then in this main folder we'd still have our main assembly. Okay, we don't have to worry about that for this case, just to show. And then this will be 01, and we'll put a dash in. This will be the carbon fiber cube. Okay. It's also important to note that a lot of the CADs we do are meant for the purpose of 3D printing. You should always export your part as a SolidWorks part first to make sure that you always have access to edit the part if you need to make changes, and then export it as 3D manufacturing format, the second one down. Okay. Cura, which is the primary software we use for slicing CAD files into 3D printable parts, will accept 3D manufacturing format. So will most other manufacturing softwares, anything like that. SolidWorks itself has a bunch of slicers and stuff built in for different machines. You can also export as JPEGs, CATIA graphics, Adobe, DXF, a million different things here. And you're welcome to play around with that. One other important one to note is step. So SolidWorks is a SolidWorks dependent file type. Step is not. So for example, there are people on our team who, for example, may not attend these SolidWorks meetings, but may use some other CAD software. So for example, Brian, being one of our more talented CAD engineers, he uses primarily SolidWorks, Fusion 360 and CATIA, because he's aerospace, he never learned SolidWorks, he doesn't have access. So for him, Fusion 360 is his comfort software, right? So whenever I share a CAD with him, I export this as step so that he can open it in Fusion 360. SolidWorks he will not be able to open, he will not be able to convert on his own. He'll have to send it to me to convert for him, okay? Just keep in mind that it can also be useful to export your files as step. The only thing you have to remember is you can never take it from step back into a part. You lose information when you make that change, okay? So just keep that in mind as well. Alright, so we'll say this is SolidWorks 1 carbon fiber tube, SolidWorks part, save. Great, okay. So we can see our orientations down the bottom. We have our X, Y, and Z axis. Okay. I'm going to go through a few more things and we'll take a 5-minute break. So we've gone over basic sketching in 2D. We did a little bit of dimensioning. We did extrudes. So we're going to look at fillets and chamfers now. So the correct pronunciation is fillet and chamfer. I hear a lot of people in, especially lower years, call these like a fillet and a chamfer and all these kind of wacky names. It's not that hard. It's a fillet and a chamfer. It's not some fancy French name. I know everyone's disappointed when they hear that, but it's the truth. Sorry. Okay. Yeah. So fillet is what we do to round corners. Okay. So this is kind of a typically lazy way to make parts look much better. These cubes look great, but if you click on the edges of each of these, the top face of the cube, it'll bring up this window, right? You hit fillet, it'll bring up this window. I always have it on either partial or full preview, just so you can actually see what it's going to do, and you can adjust the radius accordingly, right? And so what this is going to do is just going to round the corners evenly by this amount, right? So let's say we wanted to make the top half super rounded, right? 500. So much to the top will become a point. You really don't need to deal with most of these parameters in this one. You can change the way that the rounding is done, but if you leave it on circular, most of the time it'll be fine. I wouldn't even touch the rest of these, to be honest. Just make sure that it's filleting the right things and that it's symmetric. You end that and then you'll get this kind of curved shape, right? It's also important to note that you can fillet, right? So I can now go back, right, to this shape, and if I wanted to make this fully round, right, I can now click on these edges here, right? If I hit this again, right, now we have this shape. Okay, so until your part is fully round, you can just keep filleting something. So it's an easy way to make kind of lazy parts. This, say we wanted to make the end cap for our bicycle handlebars. This would be maybe a dual usable part for that, right? There are better ways to do this that are more defined, right? This is fully defined part. You don't see any errors. You don't see any underdefined areas here, but it's not the best way to do this. Okay, and we'll get into that later. Next thing is chamfer. So chamfer does basically the same thing, except that it does basically a cut operation on the corner, right? You can see this is it's kind of like a 45-degree cut on the corner, right? And so that is, and these are all akin to manufacturing operations that are done typically by CNCs. You would take a part like this and basically cut away the corners, right? These ones, we use a little bit more detail with chamfer types. So right now, this is a symmetrical one. So the distance on the top side, and let me just extend this, make this 500. It's easier to see. Sorry. Okay, so 500, so you can see that this is kind of making a point here, right? We can also change this to an asymmetric one, right? So right now it's symmetric, we can make this asymmetric, right? So say I wanted to make it 250 by 500, right? You can change basically the angle of this. So say you wanted to cut a house, for example, and you wanted to get the roof to a certain height, you could use this to change the angle of the roof, something like that. There's a bunch of different applications for this tool. It's very, very useful. Once you're done, hit OK. And again, you'll see that. And then, of course, once again, you can also chamfer a chamfer. You can click on the corner. I wouldn't do something that extreme. Let's do something like that, and you can see we now have a chamfer. And you'll see that typically most, specifically injection molded parts. So if you ever get something from, I don't know, Dollarama or wherever you get stuff from nowadays, parts will generally have a lot of chamfers and a lot of stuff like this on them. You typically won't see something very blocky like this. You'll typically see something smooth. Mostly just because it looks nice, to be honest. That's a big motivating factor. The second is when you're designing molds for plastic, you want them to be as smooth as possible. It makes it a lot easier to get the parts out of the molds. And typically, one of the biggest use cases for chamfers is, for example, this would not be a moldable part. The reason for that being is that, these chunks here, right? These surfaces are perfectly parallel. You see they're 90 degrees, right? And so if you were to put this into an injection molded part, you wouldn't be able to get it out. Right? If you tried to pull it out, there'd be so much friction on the sides between the part and the mold that it physically would never be able to come out. You need some kind of angle in, right? So what we would do for that is we would take a chamfer, an asymmetric chamfer on this corner. Right, asymmetric. This one we want to be 500 because it needs to go all the way down. And then we would take that in, and we just want an ever so slight. Typically, I think the industry standard is about 3 degrees. So maybe let's make this like 20, 30. I don't know exactly what would be 3 degrees. Not really relevant to calculate it, but you would want to do the calculation if you were doing it. And so see now, this is now no longer 90 degrees, but it's off by a little bit, right? This would be much more mass manufacturable of a part now, right? Okay, so I'm going to back that off. And we will take this opportunity to take a 5-minute break. We'll be back at like 7:05, so quick 4-minute break.
Jeremy, sorry.
Yep, no worries. So
I couldn't see the asymmetrical and symmetrical option when I was doing the chamfer.
yep, so
Chamfer.
if you
When
go
I
to
was
the
doing
chamfer tool,
chamfer.
at the top here, right? So right now you shouldn't see it at the bottom. There's an angle option. So if you wanted to force, for example, that 3-degree angle I'm talking about, you could do that here. But the asymmetrical is in these options up here. So you see right now,
Okay.
we're doing angle distance. That's the chamfer type. We want to do distance. That will give us our asymmetry. You can also do a distance across the face, offset face, and there's also a vertex one, right? So this one's also pretty cool.
Okay. See you in 5 minutes.
Yep, see you. I'm gonna get started. Just gonna make the new part, and we'll start in a minute. I'm gonna revert this and save. Okay, let's get started. So next thing we're going to learn is we're going to look at revolves and sweeps. Sorry, I'm just going to post. I keep jumping up to read this. Just making sure we cover everything in my little lesson plan. So I'm just going to post this here and pin just so we have this on record. We're going to go through. Okay, so we've been through sketching in 2D, dimensioning, extrudes. We're going to go through revolves, sweeps, and lofts now. Fillets and chamfers are done. Linear, circular, and fill patterns are next, and then mirroring as well. Okay. Alright, so we're going to start a new sketch. We're going to go back to our front plane again. Okay. So you should be seeing your origin back like this again on your front plane. So what we're going to do now is we're going to make, let's make like a pulley, something like that, okay? So let me just look up example of a pulley. I'm gonna use this tool as well. Like a pulley wheel, something like this. That's a good example. Okay, that's going to be our reference. So basically there's going to be a hole in the middle. We'll ignore the screw and stuff like that for now, that's fine. And there's going to be a channel in here for a rib to go through. For those of you taking Mech 222, this is one of your CAD exam questions. Will be a pulley very, very similar to this. So I'm going to put that down for now. Okay, so how do we do this? There's a few options. I'm going to define the pulley as the center of this origin going up will be the height of our pulley, and the right side going out here will be the kind of inlet, okay? So what we're going to do to do that is I'm going to grab a corner rectangle, define the bottom left corner as the center origin, and pull the rectangle up here, okay? Pulleys typically are standard sizes. Okay, so we want to keep that in mind, that you always want to make things standardized when you can. It makes things a lot easier, especially in the future, trying to match up dimensions. So let's say that the pulley is 20 centimeters in diameter, right? So we'll say this is 10 centimeters in radius. Okay, so this is the radius of our pulley. See, now everything's scaled to this. Let's say it is 3 centimeters tall. Okay. So basically what we've done now is we've cut the pulley in half and we're looking at a cross section of it, and we're going to revolve that around and make a 3D shape. Okay. So the few things we need to do to this first before we do that. One is we need. Yep.
Sorry. I think I made a sketch, but I see it on the left side where. On the left side where you can see everything front plane, top plane, I see sketch 1, but I don't see it in my screen itself. I think I deleted it somehow.
Yeah, so if you see
I can see that.
If you sketch one there, right, if you click on that and go sketch and then click sketch again at the top, it should pull you back in. It may be an empty sketch you created. That's okay.
Okay.
Let me know if you can see that and we'll move forward.
Yeah, I'm good.
Okay, good. So yeah, going back into sketch, we need to make basically that indentation, and we're going to do it in a bit of a lazy way, just to save time. I'm going to use a tangent arc here. Okay, so we have a tangent arc here, and so what this is going to do is I click on this, and it's going to follow the contour of where my mouse goes next. So you see I'm going to follow this line, and then I'm going to drag down. Okay, and you see now I'm making an arc that's going to be tangent to this line, right? So no matter where I go, it's going to be tangent to that line. And then I want it to come out, and I want it to also be tangent to this line, so I'm going to click down here. Okay. So you see it shows the tangency here. So if I click on these two, right? Or sorry, I click on the arc and I click on this line, you should see that there is a tangent relationship between them. Okay. And you see that at the top, and you see that at the bottom. Okay. And this should be a fixed 3 centimeter radius, so I should click on it. I shouldn't be able to drag it around anywhere, right? You can also see right now that we're fully defined in the bottom right corner, which is what we want. Okay. We're still missing a few things though. So one of them is in our reference pulley, which I'll pull up again. We have this center design as well, right? So there's like a little lip here, and then there's like the top shaft collar section here, right? The part that keys into the shaft. Okay, so what do we need to do for that? We know that section is going to be about here, so we'll add that. Looks something like that. We'll say that this is 45, so 4.5 centimeters tall, and we'll say that it's about 4.5 centimeters wide. I think it needs to be bigger than that actually. Let's say 7 centimeters. Make sure we're in the right dimension. Okay, so we'll say 7 centimeters, right? And so that will be the radius of that, so it should be about 14, right? So this will be a little bit bigger than what it is here, but that's okay. And then there's one more feature we need, which is the hole in the middle. We can always do that after, right, where we revolve and then we cut through the middle. But if we're trying to be optimal with how our CAD's being done, we can define this all in the same space here. So we're going to do, let's say, half of that. Okay, so this is now midpoint. So that's another relationship we've introduced here, is a corner rectangle from the origin to the midpoint of this top line. And you can see that midpoint relationship here. Okay, so this, again, I can't drag it. We're still fully defined in the bottom right corner. We now have a lot of stuff going on the screen, right? A lot of dimensions, a lot of stuff going on. So here's probably a good spot now for us to start moving into 3D. So at the top left, we're going to see the feature button again, and we're going to go to, instead of extruded boss, so we could do extrude, right? Just to show off. This will do the same thing as before. You know, you can click on a different contour, right? And this is where an example like this, for example, is really important for why this selected contour is there, right? So for example, this is what default SolidWorks will typically pick, right? But one thing we don't want is we don't want this section here to be extruded, right? So we're gonna take these, delete them. We want to make sure we don't select that outer part. So now by manually selecting it, you can see that it doesn't extrude this section even though we drew it in, right? Okay, so we're gonna drop out of that and we're gonna look at revolve now, right? There's revolve up here. Click on the axis of revolution. We're going to use this. So this origin, this line extending from our origin here is going to be our axis of revolution. And we're going to select those same contours. Okay, we're going to make sure to... Yep.
Can you go back to the extrude part? Sorry.
Yeah, sure. Let me just unselect. So make sure when you do select, you unselect these two, okay, the inner ones. And you can see that that'll pop open a hole in the middle here, right? And so you can start to see the pulley shape kind of take form. But yeah, so once you have your sketch here, right? Same button as before, but right next to it. So we have extrude boss space. To the right, we have revolve boss space. Right? So it's the same shortcut we're using, except it's doing it in a circle instead of a straight line now, right? You click on that, and the axis of revolution, we just want to be this line extending from our origin. And then we want to select these 3 contours that are the ones for our shape, okay? And once that's done, just hit OK. And you should see your part shape up. So you can see right now, I've run into an error, right? There's a little bit of the pie chunk missing here, right? You should also save your documents too. Sorry, that's definitely a good habit you should build up. Always save your documents first. I always forget to do that, so let's go do that now. What I have to do is just click on an old one and then just change the details. So this is going to be 2 and it's going to be pulley. Cool. Simple. Naming convention is maintained. And if SolidWorks crashes, we won't lose our progress. So this is a good way for us to learn how to fix a mistake. So for example, I see this. Oh shoot, I made a mistake. You know, I'm missing this slice here. First thing you want to do is like think to yourself, like where could this mistake have been made, right? Like where was the error? For this one, it's obvious. We know it was the revolve we just did, but sometimes you may have to trace back a few more steps. Like, is it the sketch that's the problem? Is it the extrude that's the problem? Is it some other feature we did? So in this case, it's easy. It's the revolve. So what we can do is click on this revolve, right click, right? And you'll have a few options here. You have edit feature and edit sketch, right? So edit sketch will pull the sketch from inside of it up so we can edit that and it'll change the geometry of the shape. Or edit the feature, it'll change how the extrusion was done. Okay. You also have suppress and a few other ones, but we can ignore those for now. I'm going to go back into the extrude. So now that I clicked that, you see we basically jump back into time to when the feature was being created. And you can see right here the issue is that this is 358 degrees and not 360, right? So you can see there's also the same options you had here as extrude. So we can also do mid plane, for example, and see it moves the split to the other side. And there's a few other ones here that won't work because I don't have them set up. So I need more surfaces. But if I change this to 360 degrees, you see the circle fully complete. Okay. And then any other operations we can do to this should be pretty straightforward. Say we wanted to now go and make that keyhole cut. What we want to do is use these reference planes that we have here, right? And say let's pick the right plane. We're going to make sure we have this highlighted as the plane we want to sketch on and then sketch on it, right? I'll drag this up. Doesn't really matter though. I'll take let's do a center rectangle, okay? And we're going to, again, use our origin because we know that's in the center, right, as a reference. And we're going to pull this up. And we're going to measure across here, and let's make it like a 5 millimeter key, okay? We're going to take this top and then align it with the top face of these, right? So make them, I think collinear should work. Yep, collinear will work. So you can see now this top line here will be in line with the top face of our part. Hit OK. And then we're going to grab another corner rectangle this time. Drag this across. And we're going to smart dimension this. Make this 5. Okay. Now what we're going to do is instead of extrude out, we're going to extrude cut. Okay. So it's the next tab over here. All the extrusions are on the left. The rest of the cuts will be on the right. So we'll click extruded cut. We're going to click on this and we're going to extend it way up, right? You can see now this will cut all the way through our part, right? For example, this may be a good case. For example, if there was something in between this plane and this surface that I did not want to cut through, but I do want to cut this, right? This would be a good use of the offset, right? Because what I could do is I could jump past that object. Sorry. I could jump past any objects that are here and only cut through the object that I want here, right? So this would be a good use of offset if there was something in the line, right? And so that's a little key there for the pulley, okay? Does that make sense to everyone? I know I went through that a little bit quickly. We're just running a bit low on.
Perfect.
Cool, awesome, thank you. Okay, we're gonna do one more quick example just so I can show off sweeps, and then I will go ahead and get started on that bike part. Actually, sorry, before I do that, one more thing I'm going to show. I'm going to click on the top face of this. We're going to go over fill patterns now, okay? So these are now in this section here. So you can see in the top left, you have a bunch of random sketch tools here like before. We have mirror entities and linear sketch patterns. So these are ways that you can make like a volume of common features pattern around your object. So for example, when we're working on the wheel, right, we may want to have those sprockets, those like, you know, those bars that go between the center of the wheel to the tire tube, whatever it's called. We can make, you know, some circles like this. The geometry of these don't matter. I'm just doing this for the purpose of demonstration. If you click here, there's circular sketch pattern and linear sketch pattern. So if you do circular sketch pattern, you can select around here, select the entities, which is this, right? make sure that we are using the center point as our rotation. And you can see now SolidWorks is creating a circular pattern. And so you can mess around with all these different variables, the number of units you want. For example, I'm sure you can imagine the opportunities for this are very important. For example, if you're doing some part that needs to be fastened to another, so like some plate you need screw holes in. You don't want to draw 18 of these out by hand, right? You can do one and then you mirror them around, you circular pattern them around, and then you can extrude all of them in one go and create all of those holes you need for different screws and stuff to go in, right? You can also do different types of spacing. So you can see here, I can space them out from one side, dimensional spacing. There's a bunch of different variables and stuff that you can enter here. I'll let you guys play around with that for whatever projects you need. The other one is mirror. So mirror takes an entity. So in this case, we'll take our arc and it mirrors it about a plane, right? So in this case, we don't have a plane here. What we can do is click on our design tree at the top, and we're just going to look through our reference planes, and we're going to select the right plane, okay, as our mirror. So I'm going to go mirror about the right, and you can see that it'll take any entities and then mirror them across the part about that center plane that we've selected, right? You can always make different planes too. So for example, you're making a complicated part and this plane doesn't work for you for whatever reason, right? I'll leave that mirror in place. The next thing we can do is go into features, and there's a reference geometry. Reference geometry allows us to make any type of reference we want to allow easier creation of parts. So for example, we can make a plane based off of the right plane, and we can offset that by a certain amount, right? Pretty simple. So that's offset by 60 millimeters, and now I can use this plane for any drawings I want, right? So say I want to make a new drawing, I can make that drawing on this plane here now, instead of in the center. You'll note that the origin of my drawing is the projection of the parts origin onto this plane, right? So if I'm looking at this plane, the origin will pierce through the object's origin, so this will still be in line with that center origin, so long as you keep that origin in place to begin with. This is one of the reasons why it's so important that you define your origin properly, because otherwise this origin would be in a different spot, and it would be very difficult to line up the different sketches and stuff with your original part, if that makes sense. Okay. Alright, next thing we're going to do is start another part. So I will save this, and we'll move on to the next part. One more thing to consider is whenever you make a new part, all of your other parts will still be open. You can see these ones. So once you save parts, if you're not using them anymore, you should probably close them, just to make sure that your CPU basically is not being overloaded by all the different parts that's open in SolidWorks. So make sure you don't close all of the tabs, otherwise your program will close. Okay, last thing we'll learn as a new tool today before we get into the fun part is sweeps. This one is extremely simple, right? This takes a closed loop pattern and it basically traces it in 3D, just similar to an extrude, but along any shape, okay? So what we're going to do is we're going to use the spline tool, which is this top right one here. We're going to extend this up, right? And then make a curve with it, okay? So what I did is click escape to get out of it, and you get this curve, okay? What I'm going to do here is just click on this again, and you'll open up the curves. So these are called, I think, Bezier handles, if I remember correctly. And what we're going to do is just drag these guys around a little bit to get the geometry I'm looking for. Something like that. Think of it like kind of like a drink straw, something like that. Kind of what we're going for. Soda can kind of straw. Okay. So that's what we're gonna do. We're gonna make a soda can straw. Okay. Now we're gonna click exit. Right. We don't need to be in the sketch to do an extrude on it. Right. So that's kind of our general shape. We're going to go to features, and we're going to go to swept boss /base. Okay. We're going to click on that, and we're going to collect two things. So one, you can either do sketch profile, where you can predefine what the pattern that is going to be extruded will be. So if you wanted to, make some custom shape, you could do that. Or you can click circular profile, and what that'll do is when I select my spline, it'll create a circular pattern. So see, this is the sketch that you would make, and then it pulls it down across that line. So let's say 10 centimeters is pretty big straw. So let's say like 7 centimeters. Okay. Click enter, and there's our straw. Okay, so that's our straw shape. That being said, a straw would not be particularly useful if it was, full of material. So what we're going to do is we're going to hollow it out. That's another tool. We call it shell. Again, there's easier ways to do this, more complicated ways to do this. What you could do is you could now go and sweep cut, right? So use a swept cut using a circular profile, right? You could use that same sketch, right? Say I wanted to make it 6, I could cut out the center this way using a cut sweep, right? And you can see that works, right? It works just fine, right? It follows the same pattern, cuts the center out. But it's a lot of steps. There's a lot of things you have to click on. In CAD, we want to be efficient with what we're using our energy and time on. Stuff like this obviously is very, very quick, but when you get into more complicated CAD, every single click takes time, and especially when you do stuff with surfacing and stuff like that, it can take a long time to make individual parts and individual sketches. You want to do it in the most efficient way possible. So shell is a really good method. What you do is you click on each face, right, that you want to be open in your geometry. Right, so I selected these two faces. Okay, top and bottom faces, and hit shell. And we want to make that 1 millimeter, so that's going to be the thickness of the outer shell. And I click OK. That will shell the part, which will create a cavity on the inside, basically turn the outside into a shell. Okay, so that's an introduction to a few of these tools, and we'll use them more as we get through some different CADs and stuff like that. So if you don't get the opportunity to follow along with this one, that's okay. We'll see more of those in next week's parts. Okay. Last thing, I'm just going to save these as O3-straw. I'm going to close out these parts. Now for the fun bit. We're going to get into our first part of the of this guy. Okay. So first thing we want to do whenever we are designing a part from scratch is have a general idea of what we're making, right? So what we're going to do is we are going to take some pictures of this, and we're going to measure this part just to get a general idea for what the dimensions should be. Okay. So I'm just going to zoom in a little bit on this. Try to get that roughly in the middle. Okay, and I'm just going to grab a screen capture. This guy, you don't have to follow along with this, just take a look. We're going to grab a screen capture of this. Okay, I'm going to save as documents, put it in the Solidworks folder. This will be, we call this shaft reference. And I'm just going to write 4 on this so we know what part we're referring to. Okay. And I'm going to go to this tool here, which I'll post in the chat as well. This is called leaf.net. It's a photo measuring tool. Okay. So what this does is you can open an image. So we'll navigate back to that image. Okay. And giving it a known dimension. We can scale the rest off of it. Okay. There's many ways to do this. There's even tools inside of SolidWorks, but I've always used this one just because it's simple. And what we're going to do is we're going to scale it based off of the wheel. So I know the wheel on this bike is 28 inches. Okay. So I'm going to enter that as a known dimension, about there. 28 in inches, right? And then we're going to click on our reference dimension. So I'm going to click from here to here. Try to get it through the center as much as possible. That will give us our long axis. We're going to grab this one and grab this one. Okay, well, so we'll grab those. So we're going to say long axis is 9.42 inches. The short one is 1.19, and short 2 is 1.87. I'm going to just sorry, I forgot how to remove these. Okay, I'll just put the known dimension back in. It's 28. And we're just going to verify the center should be about 1 inch. I'm going to say the shaft is 1 inch, even though it reads 1.12, just because I highly doubt they put a 1.12 inch shaft in. It's probably just some error in our measurement. So I'm going to put that in as 1 inch. And the small one here is probably about half an inch. So I'm just going to put in half an inch for. Okay, so those are our dimensions. I posted them in the chat. Right, next thing we're going to do is just do a unit conversion. So I'm going to do inch to millimeters. So we'll do the first one, 9.42. Okay, so that's 239. So we're just going to round that to 234, or 240, sorry. So 240. The next one is 1.19. Round that to 30. Just want to work with nice even numbers as much as possible. All of this is approximations anyway, so 1.87. That's 40. Let's say 50. And then 1 inch we'll just approximate as 25. And then 0.5 inches will approximate as 12. Okay, so those are the dimensions in millimeters that we're going to be using. And then we also need to take a look at the thickness, which I'm just going to do by eyeballing. We can take a look that this is going to be about 1 inch. So if we take a look at the length of this, or the width, sorry, it's about half an inch. It's about half that size. So we'll say half an inch, okay? So let's say 12, this is going to be 12 millimeters thick, okay? Okay, next thing we want to do is, because we're using a picture as reference, what we're going to do is find our front view, okay? So if you remember from earlier, what did we define our front view as? Our front view is going to be the orientation, which gives us the most information. Now there's two options here that I would consider valid. One is this. This gives us the holes, right? The information on the holes, and it gives us the shape of this. And the second one is the top view, right? We know the top view is valid because it gives us a lot more information on the general overall shape. So what I will say is either one is doable, but I would say that this being your front view would be easier to cut out first. But from a part perspective, this is probably the more accurate front view. Okay, so we're going to use this as our front view. So what we're going to do is we're going to take the same picture we have, and we're actually going to bring that into Solidworks now. So we're going to click New to bring up a new part. We're going to select a sketch on our front plane. Sketch again on our front plane. And what we're going to do now is we're going to go up to the top and open up this window here, okay? And we're going to do insert. Or sorry, tools. I lied, tools. And then in tools, you'll see about halfway down, you'll see sketch entities. Okay? There's the sketch tools. Sorry, I haven't done this in a while. Sketch tools. It's in sketch tools here. And what we're going to do is scroll down to the bottom and insert a sketch picture. Ignore everything else here. There's like a million things you can do with this program. Try to put blinders on and focus on what you're doing. You can always take a look at all of these later. We're going to add a sketch in. And this will prompt us to give us the location of the sketch. So we're going to pull up that shaft reference. Okay. And so what this is going to do is it's going to pull up this, this picture. Okay. It's going to put the bottom left corner under origin. And this is also going to ask us for a reference. Okay. So what we're going to do is we're going to take this to the bottom and top. Here. About there. Okay. And we can also scale this. So this is going to be 28 inches. Okay. And so now this is also to scale, which is very important as well. Okay. So I'm going to go ahead and drag this because I want the origin to line up as much as possible with the center of that circle. Okay. So just line that up about there, and we're gonna hit OK. And once you hit OK, this picture is now locked in. You won't be able to move it. Okay. Best thing I would say is exit out of this sketch so that you don't accidentally delete or screw with this photo. And this will now be a part of your drawing, and you can hide this later on to make sure it doesn't interfere with what you're doing. Okay. We're going to go in, make a new sketch. Okay, we're going to select that same front plane again. Zoom in. And we're going to create some circles. They may not perfectly align with that, and that's okay. We're just using that picture as a reference. Say about there. Okay, and what we're going to do is use some lines for these, and we want our lines to kind of line up with the top and bottom of these, right? So we want the circle origins to kind of connect with the tops of these, just to make our part a little bit better defined. There's two ways we can go. We can go a tangent arc. Let's see how much that lines up. That's not too bad, right? That's pretty close to what we're looking at, so we can use the tangent arc. Let's see how this goes. That side's a little bad. What we can do is click here and maybe just adjust these a little bit. Right? That's not too bad. Okay, and so these should now be the roughly correct dimensions as well as scale for what we're going to do. Now, before we do anything else, right, what we want to do is define the size of this, because even though these are the same size, we haven't entered in a dimension into our part to define this. So we're going to make sure we enter this in first. This is a known dimension, this circle. So we're going to enter in 25. Okay, so now this is scaled this part to those sizes, right? So you can see that our outside picture has shifted a little bit, and that's okay. The interior, our part, the relative sizes should all be the same. Okay, so I'm going to take this out now here. I'm going to make this 12. I'm going to take the front point of this to the back point of this. Make sure I'm getting the proper dimensions. You can see here, Smart Dimension is taking horizontal, which isn't really correct because it's not tangent to this circle. But if you pull in pretty close here, you can kind of get the tangent right there. So this is going to be 240. Okay, and then we want short 1, which is going to be this dimension. Short 1 is going to be 30. We know long, or short 2, sorry, is going to be 50. And then we know, let's see now. Long, short. Okay, so that's all of our dimensions. What else we're going to do right now? So for example here, there's one relation that's been missed. So I can see that at this point here, visually I see that there's no relationship between this and this, which this should be a tangent relationship. So I'm just going to go ahead and add that. You can see that that already looks a little bit better. You can see that I'm also missing that here. I'm going to make sure that's there as well. Adding those tangent relationships again. Just going to go ahead and move these down a little bit. Okay, we're going to make sure this should still be aligned with our origin. Great. So this we want aligned with our origin as well. So we're going to make sure those line up. Okay, and we're going to drag this down. We should line up pretty close with what we were looking at. And then we want this circle to be concentric with this one. Okay, so I'm using a few shortcuts here. I'm going to go through that again. But basically what I'm doing is I'm grabbing the center of this circle, right? And I'm just lining it up with the center of this arc. Okay, so the less shortcutty way to do that is select the outer arc and the inner arc, and you can set them as concentric. And what concentric means in CAD terms is the center points of each arc and circle are locked together. Okay. So you can see all of the dimensions we need to match the size of this should now be in. The only thing we're now missing is the fact that our drawing is still underdefined, right? The reason for that is we have this, right? So you drag it around, there's still something missing, right? Actually, I don't know why that circle is jumping. That shouldn't be jumping. Okay, we're gonna set this dimension. We'll lock that to 25. Yeah, I thought that was overdefined. I don't know why that's doing that. It's the okay. Okay, so what we're going to do is we're going to add another line between the 2 points, and we're just going to make this horizontal. Okay, and that should get rid of most of our problems, yeah. So you can see now, everything's gone black, and you can see that we are now fully defined. And these are the correct dimensions for what we're looking at. You can see it's very close to the picture of the model. It's never going to be perfectly on because there's a lot of different errors we're seeing here. One, for example, is the perspective shift from this. We're looking through the center of this axle, which means the wheel is warped. So the reference dimension we put in is not technically correct. You know, even between the length of the shaft, there's going to be some distortions and stuff like that. So given all these things, this is a pretty good approximation of what we're looking at. And just again, keep in mind whenever you're doing CAD like this, always make your dimensions like round numbers in a known format and in a known dimension, preferably in millimeters. It'll make your life and everyone else's lives around you a lot easier to deal with CAD. Fitting parts together that are standard dimensions is much easier than fitting, you know, random stuff together. So keep that in mind. It also reduces the need to measure things a million times because if you know everything is 3 millimeters, you know everything's 3 millimeters, you know? So what we're going to do now is we're going to exit this sketch. And I want to do some more manipulation on this, but what I want to do is get rid of this because this picture is now no longer helping us and it's kind of getting in the way. So we're going to go right click on this and we're going to suppress it, right? So this third option here, not edit, but suppress. That'll get that out of the way. So now we're just dealing with this shaft, okay? One more thing I'm going to do is I'm going to pop back in, and this center line I'm going to set as construction. So you can see here, I'm going to set it as construction. So what that's going to do is once we exit out of the sketch, okay, you can see it's now a dotted line, and this won't affect any of our extrudes and stuff like that. It's just going to be there to help with defining the geometry. Right, so you can see, again, we're still fully defined in the bottom right. Okay, next step is we are going to extrude this into the third dimension. Okay, But before we do that, there's one more thing we need to consider. So if we go back to the model, the 3D, what we're going to do is look to the top. Okay. So one thing we do know is that we know that the thickness of this is around 12 millimeters. Sorry, but what we don't know is the shape of this. Right. So that's the next thing we're going to tackle. And I'm just going to try to pick maybe somewhere in the middle here to kind of hover above. I'm going to grab another picture of this. Okay, save that as number 2. I'm going to pull this up in a leaf again. Just refresh the page. Okay, and we know that the dimension here, right from the front view, is 240 millimeters. I'm going to use that as a reference this time. And what I really want to know is the thickness from here to here, let's say, which is about 48, which is kind of our stock material. So if I kind of grab this across the reference line, right, what we want is this dimension. So let's say 42. And that's what we're going to make the thickness of our stock before we cut out this top shape. Okay. So we're going to go and we're going to extrude. And we're going to go ahead and select this sketch. Extrude. We're going to do mid-plane because we want to maintain our origin. Right. We want to maintain our origin at that point. So we're going to do mid-plane to keep that in the middle. And then we're going to do... actually, sorry. In this case, we want to do blind. The reason we want to do blind is because we're cutting this apart. We want our origin to be right here, if that makes sense. Sorry, get rid of these. We want our origin to be right here so that we have a known dimension. Otherwise, if we do mid-plane, the origin's going to be somewhere in the middle floating, but we want it to be along the edge here. So that's what we're going to do. So we're going to make it blind, and this is going to be 42 millimeters. 42. Okay. Now, what we're going to do is we need to cut out the top shape, right? So we've done the front, and the front lines up pretty well with what we were looking at before. We're going to do the top shape. So we want to find the top plane here, right? And we're going to go ahead and make a new sketch. Now you have a few options here. You can do the same thing we did before, which is an option of we can go ahead and do tools, sketch entities, sorry, sketch tools, sketch picture. You can go ahead and pull in that shaft reference again, right? This is probably the easiest thing we can do. We can use that same dimensional trick, so we can pull from here to this here. To around here and say that's 240 millimeters, right? And so this should scale our part effectively. So we can basically overlay that here, right? You'll see one problem immediately is that the picture is a little bit rotated, which means that the part's not fully within it, which is okay. So what I'm going to do is I'm just leave this outside as a reference. And click OK. You still have to pull these pictures in and stuff too if you don't want to. That's not a big issue. Main thing is just getting the geometry of this looking close. Okay, and so now that we're in this dimension, one really useful thing we can do is project this image or this object down onto our 2D plane. Right, so what we're going to do is select the faces, the outer faces here, and use this convert entities button, right? And what that will do is it'll take the intersection points of the 3D object and then map them down onto this plane. It just makes it a little bit easier for us to do things with knowing exactly where they're going to line up, right? Okay, so we want to do a few things first. We want to figure out exactly what we're going to do. So if I'm looking at this shape here, right, I can kind of break it down into sections. There's a section here, right, easy section there. There's an easy section here that are squares, right, and then looking at it, there's kind of like two breaks, right? There's one here. Oops, sorry. There's kind of one here, right, at this corner. So maybe we'll do here to here. And then we'll do like here to there, right? That kind of follows the pattern pretty well. You know, a little bit of deviation here and there, but that's quite okay. Maybe just adjust this a little bit to like there. Right? And that pretty well captures the essence of what we're trying to do. So I'm just going to go ahead and copy that. So we're going to grab a box like this and a box like this. And then we're going to grab 2 of these and then 2 of these. I'm being careful to click in places where relations are not being added to simplify how I'm going to change this in the next step. Okay, just going to do some measurements. Grab these. So this is 63, right? That looks to be around okay. So I'm just going to round that down to 62. Could even go as low as 60. Be fine too. I'm going to measure this side. It's 51. Let's make that 52. Okay. So that should be pretty lined up now, and we're just going to grab the angle here. Okay, so that's 18.33, so let's make that 18. 18. Okay, we'll take the angle from here to here, and we'll see that's 11.8, so I'll make that, say, 12. Is that going to work? No, why is that not work? Because this distance is off. Okay, sorry, I need to also define these are going to be 12. Basically, you just want to punch in all of the known information you have about your part. Make sure that you keep all of the important information. Okay, about 12. Maybe let's do like 8. Is that close? Nope, let's do 10. A little bit of guesswork when it comes to shapes like this when we're not doing exact matches, but it's okay. And then what we want to do with this one actually is we want to just make these, the distance between these, sorry, right, so now that we know that this is the shape we want for the top side, what we're going to do is actually add a relationship, because you want to make sure that this sprocket remains the same size all the way through. Right, what we're going to do is remove that dimension, and we're going to make these parallel to each other. Okay, and what that will do is make sure that the angles are the same, parallel, and we're just going to make sure that the distance is 12. Why is that not working? So see, that accidentally added in a relationship here somewhere. Why is that there? Okay, I think probably just due to the geometry. Where is underdefined? This is a technique I use when I'm trying to figure out what is underdefined. I just select everything and drag it around. I think maybe just this top section is underdefined. I'm going to remove this now. So yeah, that was it. So you can see now in the bottom right corner, we can see this, this is fully defined now, right? So what I'm going to do is I'm just going to go ahead and delete the sketch picture, because we also do not need that. Okay, so now we have our shape. And what we're going to do is we have this, we have the shape, and we have our material. But instead of doing extrude, right, which would just add more material, we actually want to remove material now. So what we're going to do is we're going to go back and we're doing extrude cut. And we're going to do a mid-plane extrude cut. We want to extrude everything that isn't within this range here that we want, right? So we're just going to select here, 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 and here. Okay? So what that's going to do is it's going to select everything and give us that shape that we want. It's important too that when we do mid-plane cuts, there's a few other options we have. We have through all and through all both. So typically you want to use through all when you are doing individual parts, but you want to be very careful with this, because if you ever want to make something outside of this and you change the orientation of, or the order in which you make operations, sometimes through all may cut through other stuff as well. But you see in this example, this does exactly what we want. So we're going to hit OK. And we can see that our little sprocket gear thing start to take shape. Now, there are a few other ways to design a part like this. You can do it a lot smoother using surface modeling, right? So that's where you design the splines individually, and it'll make the part a little bit smoother. But one thing we can do here is using that fillet tool that we used before. We're just going to smooth out some of the rougher edges here. And the exact size of the fillets generally are not known or not really highly calibrated. It's just to kind of smooth out the look of it, right? So we're going to do this on the major ones. I'm going to pick radius 140 just because it seems to look pretty smooth in the way I want it to. So I'm going to select OK. Okay, so you can see it starts to smooth out quite a lot already. And then what we're going to do is do another one around the edges. Right, and this should select the entire edge around both. I'm just going to work my way up a little bit until I see something I kind of like. So maybe we'll do a 6. The 6 is half of 12. We know the dimension is half, so if we're doing a circular pattern like this, 6 should give us basically a perfect curve on the top and bottom. So if we do that, we can see our part just kind of take shape there, right? At the top as well, you have a few different options here for how your object is displayed. So you can see we have our shaded with edges, which is typical. You can also see shaded, so this kind of is a more photorealistic look to a part. We have outline, so you can kind of see a basic version, so they might be in a drawing. Outline with the dotted lines showing the sections that are outside, and then you can also show a more solid shape as well. Okay, that's kind of our first bike part done. I think that's probably where we'll call it for here. I'm going to do a few little just kind of aesthetic touches just to show you guys what is possible, but as for adding, that'll be it for this this session. Yep, go ahead.
Okay. Can we add the carbon? Can we change the material to carbon fiber?
Yep.
Now, or do we have to do?
I was just about to do that. So there's two ways to do it. One way is using the carbon fiber material, right? The other way is you can do it visually, right? So I'm going to do it visually this time, but basically the material here, if you wanted to, you can change it to carbon fiber using this material option here. The other way is you can select this this little appearances scenes decals button and drag the carbon fiber epoxy or any other one on and get that on, right? And you can see that looks pretty good. Another thing you can do with these is you can actually change the appearance. So if you go to this little menu up here, right, it'll pull up the appearances. So you can actually change this a little bit. So for example, if you want to change the surface finish, you could change what it is, right? If I want it to be knurled, sandblasted, or cast. Obviously, most of these don't make sense for carbon fiber, but there are options that do make sense for other ones. We can change the color and image, so you can actually change this to anything you want. You can put decals and stuff on it as well, which we'll do in a second. You can change the lighting on it, how it's affected. The other one is the size, so you can see we can change the size of the carbon fiber mesh that we're using. This is mostly based on aesthetics. Probably something around there is probably pretty realistic, so we'll probably leave that. Okay, I'm going to leave this as shaded too, just to make it look a little nicer. Something I like to do with my carbon fiber as well is I like to add a black tint to it, just because I think it looks a little bit nicer. Just add a little bit of a kind of gray tint to it. I think it looks a little more carbon fibery in CAD. And then one last thing I'm going to do is pull up this picture. Oops. My reference. I'm going to take a look at this. Oops. Okay. Quickly going to pull up paint. Actually, I should pull up paint. Damn that. Okay. Just gonna quickly delete the background. What we're gonna do is brand this, so we're gonna go ahead and let's throw on a nice font. This is obviously not necessary for you guys to do, but just for the sake of
Do
the
Comic
tutorial,
Sans.
that's a fantastic idea. Where's Comic Sans? Comic Sans, somewhere here. Comic Sans. This one? That sounds good, right? TMAV. Goofy ass
Perfect.
TMAV. Okay, shit. We'll make it bold. What's our logo color again? It's a yellow. Can't remember. Yellow, black. Let's do it yellow. Yellow will look good against the carbon fiber.
Yeah, it was yellow goldenish.
Okay. We'll do some yellow. It kind of looks like it. TMAV. And then we'll do another one. This one will be small. We'll do TM. TMAV, TM, and then what do they have? XXT or something in some other weird font. Let's find some random weird font. Some random kind of assembly looking font or something. Do like XXR or something. I don't know, something random. I'll make this like 280. Oh shit, not that. Oops. XXR. It's maybe a little too big. Yeah, something like that. Okay. Cool.
Dang, that is some Crash Bandicoot looking
A little bit, it's okay.
looking font right there.
That's okay, that's what we're going for. It's supposed to be a little memey, okay? Where's the crop button? There we go. File, save as. Where's it? Here. So put this as 4 decal. Okay, and then we're going to hop back into the part. And we're just going to go ahead and click decal. I guess it's over here, sorry. Decals. It doesn't really matter which one you pick, to be honest, because you're going to change it, so I'm just going to throw it on here. You always have to do decals in parts, by the way. You cannot do decals on assemblies, which is actually very annoying. It'd be really cool if you could do that, but you can't. So we're going to change the image path, and we're just going to go ahead and grab our little decal. You have to check one of these boxes. Mapping. I haven't done this one in a while. There's like a mask. That's something we have to change. Hold on. Maybe you have to add the decal fully first. Okay. This is an extremely laggy part already. Sometimes parts get extremely laggy and I'm not quite sure why. Let's see if this works. That's cool. Yeah, doesn't seem to be working. That's kind of unfortunate. I'll have to mess around to get that to work, but yep, that's our part. So last thing we're gonna do is we're just gonna go, what the why is that showing? Ignore that. I don't know why that's there. Oh wait.
You might have control edit one extra time.
Ah, I see. That's unfortunate. Do we have history? Okay, it's fine. Whatever. Hold on. Just gonna have to redo that last bit. That's fine. Okay. How did that go? Did that last part go? Were you guys able to keep up with the last part? Or is that a little too fast? Hello?
It was fast for me, but I think I'll go back to the recording and finish it off like afterwards.
Cool. Yep, that's good.
Yeah,
It'd
yeah.
be really cool at the end to get through all the parts, because we'll be able to assemble it and kind of have like a working model. I really do think that this is a really good reference model for basically anything you need to do in CAD. So I think basically everything we'll need to go through will be good. Especially once we start getting into doing more like TMAV specific CADs later on. Once we get through this project, it'll be very good practice for everyone for sure.
Yeah. How do you if you're doing it in an assembly, right? How do you know all your parts will like fit together perfectly?
So that's a good question. And the answer is you sometimes don't. Sometimes you assemble them and then that's when you realize that they don't. The reason why we use CAD to begin with is so that things like that happen in CAD and not in real life. Because typically what will happen in real life is when you don't spend the right time doing your CADs, you'll take two parts and then you put them together and realize they don't fit together. If your CAD matches what you have in real life, you'll figure that out first, right?
Yeah.
That's typically when you want to find out, not after you've manufactured the part. Generally, what you want to do is have a kind of an idea of what you're going for before you do the CAD model, and you can kind of keep track of what the dimensions are, and stuff like that. A lot of it depends on your specific application. Like if you're doing custom parts and you're designing everything from scratch that's going to fit together, you kind of have yep, no worries. You kind of have a little bit of freedom over exactly what what parts are going to make what sizes and stuff like that and how you're going to interlock them. But if you are if you're designing like off-the-shelf parts, you want to make sure that whatever parts you're getting interlocked together before you even put them into your CAD, right? So you don't want to buy a part that takes an M4 screw or an M3 screw and then you have like a 1/8 inch screw instead in your CAD, right? It'll be very close. M3 and 1/8 inch are 0.1 millimeters off from being the same size, but they'll be ever so slightly different. And there's tools in the CAD software that you can use to detect issues like that, even when it may not even be visible to you that there's an issue. But yeah, tools like that will be very beneficial for you.
Yeah, all right.
Okay, I'm going to go ahead and stop the recording there, guys. Thank you.